Okay, that's quite a drop in persons, but anyway. Let's hear from Nelson and Luke. Luke, right? Luke, about migrating a lot of databases to the cloud, something that seems to be popular for whatever reason. Well, we'll see.
Okay, well,
Have fun.
thank you. Well, thank you for coming. Here we are to show you some experiences for a project that we're working since the end of last year. The idea is to show you a brief description of what we did with some background about the decisions that we make and what challenges that we faced and how we resolve it. We have a lot of content. Actually, we wanted to share almost everything, but it doesn't fit in 45 minutes. So what we have is a lot of slides that we are not going to cover, but you can later download and then see some code actually at the end. We left that as the appendix, actually. So I'm Nelson, and Luke, he's here with me, a colleague. We both work for Pitian as principal consultants. I've been working on IT since I graduated, mostly with Oracle. Recently, I don't know, 5 years probably with PostgreSQL. And well, Luke?
Yeah, well, yeah. So I've been working with Pythian for 17 years and working with databases for over 30 years. So yeah, a similar sort of thing.
Nice. And well, we work remotely. The company we work for has people everywhere. So it's really interesting. So you can check the website. We are looking for people all the time. I think we have some job posting in the board also. So what we actually were asked to do is something that everybody probably at the first time says, well, this is simple. There are a lot of tools that can do the job. So how hard can it be to migrate some databases, no? So we were approached by this customer that had a lot of old databases, no, using Postgres 9.6. And they have a few servers, no, 10, with 100 databases in total in those servers. And their challenge is they wanted to do it with minimal downtime, that migration, and to managed services. They were running on VMs. And the idea is they were using also some extensions. And they say that they have tried some tools that give them some problems. So they were not really confident that they could do it by themselves. No? That is what they approached to us. And they mentioned a couple of tools that they tried. We listed here, no? DMS and streams, because they wanted to achieve the minimum downtime. No? And the initial thing they said is some tables didn't have primary key, which is usually a challenge when you have a replication tool, because usually you need a primary key or unique key for that. No? But when we engaged and started to discuss with them, we discovered a lot of other things that they also needed to resolve. There are a lot of details there. You can probably read it later. But the main one is thing that they wanted to implement a lot of things because as they were moving to new servers, new versions, why not to just get rid of all data, to use new features of the database? So they were using manual partitioning when inheritance in 9.5, so they wanted to move to declarative partition. So they mentioned a lot of things that they wanted to implement. So it was not just a migration, no? So we discovered those things during the initial discussion with them. The other interesting thing probably is they had a really tight deadline. So they say, well, we want to migrate everything before the end of the year. It was like September. And the only good thing of all this was, well, the tables that didn't have primary key were insert only, which means logical replication could handle that because there is a way that you can just say, handle only the inserts, don't care about the updates, and it works. So with that in mind, we just jumped into the idea, well, let's try to propose something, no? So that is what the idea of what we propose, say, well, let's do some proof of concept first with a few databases, then do some capacity planning because they also wanted to change the mappings of the databases to instances. So they wanted to take the chance that some applications were a bit integrated with others, but on different servers, so they wanted to consolidate that in a way that the applications were like mapped to servers. So part of the customizations, no? So let's say, well, let's do some capacity planning because when you change the allocation, probably the servers need to be sized differently, no? Then we proposed to do some automation because they had a lot of databases. So we say plus than 100 because on a single environment that they had that, but they have several environments. So in practice, we migrated like 250 or something like that, because we did pre-prod, prod, and some dev databases. And of course, behind all this is the provisioning. They want also to have automated provisioning. And because they were going to the cloud, this was in GCP. So we wanted to use Terraform. They had their own DevOps team. We had also our DevOps team. They took care of that, but it's part of the project. Then the idea is we do the migration with the automation that we created, and we planned some cutovers in the sense that not all the databases were migrated at the same time, so it was not a big bang. So we had to do some batches of databases. After that, the application testing happens. We did some optimizations on the environment. We call it cost optimization because we are in the cloud, so we try to just reduce the sizes or increase it just to avoid paying more. And then we repeat everything for the next environment. No? So that is the idea of the project. And of course, here I say with colors probably the different stages of the project. No? So those 4 biggest stages. This is to give you an idea of the architecture of the migration, in the sense that on the left, you have here the VPC with the VMs, with all the databases, the source databases, and they are migrating to Cloud SQL, which is when you deploy a Cloud SQL database, which is a managed database in GCP, it has their own VPC, with their own network. It's not enabled to communicate. There are ways to make them to communicate with each other, which is using some called PSA, networking settings on the configurations that should be done when you provision, so you cannot change it after the services are provisioned. And then on the managed databases, they wanted to have no primary key, no public IPs. So that means that you need to create some endpoints where the application connects to. It creates, it's something known in GCP, but you need to do some extra work. It's called PSA. So the applications connect differently too. And the idea is the VMs with the applications are also in GCP, and the clients connect from outside. No? And we as DBAs could connect this way too. So that means, just to quickly describe some networking complexity, we spent some months probably with all this discussion about how to set up this. Of course, it was the other team, it was not ourselves, but we had to engage in those discussions, because when you have to enable replication between these two, it only works if the proper networking setup is in place. No? So there is a lot of troubleshooting here that should happen for you to make sure that everything is working. No? So, but let's focus on the database as part of the project. No? So the idea is, initially, we spent some time exploring the ways that we can do this, because, of course, there are a lot of tools and documentation available. So the first is the Google-provided tools for migrations, which is called DMS, and it's free if you are using it to migrate to GCP. So it seems to be the go-to place when you are trying to do this kind of work. The customers say that they have some trouble, but they didn't have good documentation about which kind of problems. So that means that we should spend time to repeat the test if we wanted to know what happened. No? The thing is, the documentation say this, what we have here, no? That, of course, I wrote this because that is true. No? In Google, everything changes every month. When we were doing this project, the networking setup changed like 3 times over the course of the project. So we were enabled to do the final configuration just because they implemented a new feature 3 months after we started the project. So, it's great. They keep improving. And this tool too, but even today, when the documentation we checked this last year, this is the same today. It says that you can migrate with this tool all databases from the source to target. It doesn't allow you to select which ones do you want to migrate. So in this case, when they wanted to change the allocation of databases to servers, it will introduce some additional step for you to make those changes, which is, with some volume, is a lot of work, no? Or additional downtime maybe. So because of that, we say, well, we don't want to spend time on this. This doesn't look like the tool that we can use for this job, no? And the other option would be to use third-party tools, but of course, you need to pay some license for them. And the thing is, with this problem that they say that they found with one of the tools, with the streams, again, it was not well documented. They say they had bug opened with the provider. So we decided to go with PGLogical, which seems to cover well all the cases. So that is why we proposed to do a proof of concept. And the idea is you need to implement some automation, no? Because it's really easy to use PGLogical. It's a few commands to set up, but you need to repeat that a lot, no? And to deal with the different kind of issues that you find. This is a diagram that explains a bit how we did, how the migration should be, no? Because using PGLogical, because on the left you have the source instances, on the right the new managed databases, and it's not one instance to instance, it's just crossed between servers. This example is only with 2, but we have like 10 different ones, so they were a big mesh, no? We have, Luke created a diagram with that I shared with the customer. It's really a big, like 2 pages long document with a lot of arrows everywhere, no? So this to illustrate the idea that you have some changes to do in the setup of the source databases because you need to enable IP communication between the servers. You need some parameters to be changed on the source also because when you use PGLogical, you need a few settings to say how many processes are you going to use. That means 3 parameters. But because of this, every server has a lot of different logical replications because we configure replication per database. So some servers have, I don't know, 20 databases, so we have to use 20 slots just for the replication slots, and for each of them you're required to use 3. So it was like 60. Some, I think, for some we set up like 100 processes just for that because we saw some problems in the middle, no? And again, on the left is production. We didn't have downtime allowed for those doing these changes, so it was really hard to say, let's change something and adjust it later. No, we had to like do some good testing, share what we needed to do, and then execute it only one time. No. So this is an interesting part, probably. We did some decisions here. So we spent some time documenting everything that they have before starting, because whenever somebody tells you that he has something, you need to confirm that those things are true. So we created a large spreadsheet with a lot of columns covering everything in the configuration, extensions, versions, just to make sure what we are going to do. And then from those initial databases, we choose the 3 more complex, in the sense that the biggest one, the one that had more extensions or possible problems, to do the proof of concept. Then we did the capacity planning with the database and automated everything. No? I think this is basically to set the project, the idea. We are going to show you details about the things that we have here in bold, no? Just because everything of this has a lot of details. And just high level at the beginning, and we'll go to you with more details later. So the idea is the proof of concept initially, we found something which is probably obvious for people who use this, is the initial data copy represents some challenges with databases where the tables are big, no? Because PGLogical configuration is really simple. You execute a setup that can be for an entire schema or for a table, and you can add as a parameter saying, copy the initial data or not. Because we were doing this in production, the idea is you're required to have a consistent copy of everything. So there are 2 options. You could use a backup and then sync up from there, or just doing by table, no? So when you have large tables, that initial copy uses the copy command, and that takes a lot of time. So we found some problems here in the sense that we were not expecting to take that long. So some of the tables took like 48, 70 hours maybe, just because they had these schist indexes. That means that you cannot recreate those indexes in parallel. So the only way to create them is sequentially, and tables with, I don't know, it was, I think, 60 or 40 gigabytes. Those indexes were really big. That was the reason for that to be slow, no? So we had to design some optimizations for that initial data copy with the idea that here, drop all indexes that are not primary keys, and then enable the subscription, and then create those indexes on the target, no? The source, we are not touching the source. That makes that the copy is a bit faster. You spend a bit more time later recreating all these indexes, but for the normal indexes, you can do it in parallel. So we reduce a lot the time with that. The other thing is when you have the time to prepare these kind of things, you're not really pressured by this time that you spend. The only problem is that when this operation starts, it creates on the source, a snapshot, which start to accumulate walls. And after the initial data copy ends, all those walls are applied or sent to the target. So you need some space on the source to allocate or to store all those walls until the initial copy finishes. That for busy databases and large, busy in the sense that had a lot of transactions and also had a lot of data, for us, it didn't represent a problem. We did it in production. Well, we didn't initially some tests. We didn't find anything because it's really hard to reproduce that. But when we went to production, we also didn't find much problems with this. I think we, in a few of these slow really copies that took almost a day, a few gigabytes allocated only for wall files, no? But that could be a problem in other scenarios. No, in our case, it wasn't a big thing. So that is why, at the end, I mentioned that we tested the approach to use a backup to do the initial data copy. But it requires you to carefully choose which is the position where you want to start the synchronization. There are some documented processes, procedures for doing that. In our case, we didn't have replicas to do it. So we did some simple proof of concept that didn't allow us to make it safe. We will lose transactions in the tests that we did. So we say, well, maybe we don't need that at the end because we could take the time to wait for 2 days to replicate the big databases. No? Maybe it's not for everybody, but it's interesting to know that there could be another way if you have the possibility. Somebody told me that also you could use a backup and restore with PC, well, not just the usual dumps, just a physical backup. But because you are in the cloud, you can not restore a physical backup to the cloud service, no? Where you could just look at the log position in the restore, which says which is the wall that you're waiting for, no? So you have to actually do some logical export, and that has more challenges, no? So I think this is basically the 3 things that we evaluated or discovered within our proof of concept. It's probably not surprising. All the PostGIS and extensions worked really well, no? So we didn't find any problems. The capacity planning probably is something that you could be, we all are familiar with, but in this case, we needed to use by database. So it's not by instance, so there are metrics. We try to use some tool, no, as PCCLU, that could be used for this, but in our case, it didn't work well because all the reports are grouped by server in this case. So, and we wanted to play with the combinations of databases. So we actually ended up capturing metrics from the database, from the source database, manipulating that as in a spreadsheet, and created some dynamic tables to play with that. No? It's a bit a manual process, but well, it just takes you some, I don't know, some time. You don't do it, you don't repeat that much. No? So you just capture a lot of data for a couple of weeks, and then spend the time to create those spreadsheets, and with that it's enough. No? We have at the end in the appendix some examples of the queries that, or the process that we did for that, no? Some queries. The interesting part is because this was an old version of Postgres, we didn't want to enable the track I/O timing that was disabled by default, so we didn't have metrics about the storage performance. So we based those estimations just in buffers movement to give us some idea of how busy was the storage. And at the end, it worked well. So because it's really hard to also do a good exercise when you're changing versions and platform, no? So everything that you create are really estimations. So this was part of that, no? For the automation, I give it to Luke.
Okay. So how do we do it all? So basically we did it in one spreadsheet, one shell script that controlled everything. And as part of that, we've got two configuration files, two YAML configuration files. One was for what databases are going to go where, and in addition to the fact that only some databases were going to go, there were sometimes they didn't want some schemas to go. So we had like schemas lists for specific databases. So it was quite a big configuration file with all the databases listed in there and the source and the targets and all the information that you needed in order to be able to automate it. And then the other YAML file was all the different steps. So we had about maybe 20 steps from the very start of creating the database in the Cloud SQL, creating the extensions, doing the PG dump, doing the restore, setting up PG logical, those sort of things needed to be configured in there. And the reason that we did it like that is because they kept on changing requirements, or we'd find bugs or issues where it didn't work, so we needed to add new things. So we could easily add a new step into the configuration file, so it just run that step in addition. So it made it very flexible to be able to make changes and ensure that the future migrations, when we found we might be like 20 databases in before we found a particular problem, and we could fix that problem for the rest of the 80 databases. So this is kind of how it works. Which one's the pointer?
The red one.
Top one.
No, please.
Oh, okay. So the top one is the main bash script that runs. And the thing that you have to be careful about when you're running these things is, with the YAML files, is that we're actually updating one of these YAML files, but basically saying the stage that this database particularly is at, because we want it to be rerunnable. So if, for example, it ran a PG restore and something failed in it, then we want to run that potentially run that PG restore again. So we want to make sure that we know where our migration has got to for each database. So that meant that we have to update this YAML file. That has to be sequential. So we're also running this in parallel. So we can change the parallelism, and we can run 4 databases at once, or 10, or whatever the capacity of the server was. So. But the updates to this has to be sequential. So you have to manage that. You have to kind of lock that file out, make sure nobody else can write to it before you can write to it. But that didn't really affect the running of the program too much. It didn't slow it down very much. But you see, so up here is the migration script is running. It reads both these files. And then for each database, in parallel, it does all the executions of the bits and pieces you needed. So everything that you need to do there. Okay, so what do you have to do? So first of all, the things that we didn't really have to do ourselves, but we got another part of the team to do, was the Terraform to create the instance in the Cloud SQL. That's not involved in the migration part. So we're assuming that the Cloud SQL instance is already there. Then we have to basically go through this list of bits and pieces that we need to do in order to. Oh, that wasn't right. I'm going the wrong way.
The other side. I think here.
Save me. Right. So, what was it? So from like schema creation down through to making sure that we drop indexes for large tables. So we had a script that would generate the script that would drop the indexes, and then also generate the script to create them afterwards. So that is all automated. That's one step. But you try to make each step fairly small, so you didn't want to do lots of things in a single step, because if you needed to redo that step, you don't want to have to drop a load of stuff, or you want to make each step as singular as possible. Like I said, we had about 20 steps or so. And interesting, at the end, we need to do validation as well. So we need to make sure that very simple validation of does all the objects look the same? So how many objects have we got on the source? How many objects have we got on the target? Broken into indexes and constraints. And then we had some issues, you'll see later, where we had column differences. So that we had all the columns were there, but they were in a different order. So we had to put in extra checks for those sort of things to make sure that they didn't cause us a problem. We also we wanted to validate that the actual data was there. So we did basic counts on the rows, which is okay, but not brilliant. But then, so the other thing you could do is you could hash it all. But what do you do with big tables? So big gigabyte worth tables, it's going to take too long to do the validation. So we basically chose a number like 500 rows, and we just chose did a basic mechanism where we got the random 500 rows. You can only do it when they've got a primary key. So you list those primary keys of those rows, take the hash value of those 500 rows, and then compare it onto the target. So some of these details that we're not going to cover just now, but there are in the appendix later when you download the slides. Okay, so this is kind of like how it looks. So you can see, did it again. Okay, so you can give it these are the steps that you could create. So you could change. The idea was you could create different steps for different databases if they were specialized. But in the end, we kind of use the same thing. But it tells you some of the details that you've set up here. What you're going to which database you're going to use. And one of the things that we wanted to be able to do was to be fairly flexible with what databases were migrated at any one time. So in the configuration file for all the databases, we had like identifiers. Obviously, we have the source and the target, so you could migrate on a source basis or a target basis. In our case, we wanted an extra sort of arbitrary thing, which was which batch it was going to. So the customer chose, well, we want these 10 databases to go today, and then these 20 to go in a couple of days. And so we called them waves. And so we had that extra bit of information against each database, so that you could just choose when you did the migrate. You just did the migrate.sh main command, and you said, I want wave 4, and it would work out what to do based on that. And then simply it would go through each step and run each step, and as long as that step was successful, it would go on to the next step. So, just some examples of what's going on here. We've changed the names. The databases weren't called DB5 or anything. What we did do in the end was, in order to be able for us to be able to see what was going on and be clear, is that we wanted to. We built some other shell scripts that examined what stages everybody was at, so you could see in a particular wave what was going on, how good the replication was, what step it was under, and those kind of things. So
maybe to add to that, the idea, this is a very basic script that just execute SQLs, read the configuration file to create this output. No? It's not really complex, but the output maybe is a bit heavy or loaded with a lot of information, but it has everything that we need to know to when we started migrations. No? For example, there you see that the copying means that we executed a migration. It was a big table or big database, and the migration stopped just because it waited and the initial data copy didn't finish. But we can see this through the scripts, and when we see that it finishes, we just execute the migration again, and it will resume from that point and to the other steps that are needed. No?
Yeah. So once we'd finished, once we'd done the migration, we came to the cutover point, and that was done in collaboration with the client in a long call. And there were a number of steps that you had to go through that they wanted to go through, but we kind of semi-automated those steps in terms of that we wrote a script that would just run out all the steps, and all we did was copy and paste, and there was only a few, like 4 steps per database to do. So it made our lives much easier and much better, and it was relatively smooth. Right, this is quite an interesting part of it. We did come across quite a number of problems. I'm not sure that I'm going to have a fantastic amount of time to go through all of them, but some of the more interesting ones is the reusability and compatibility ones, and some of this inheritance column order stuff. So I might concentrate on that. So here we've got, so what we did is, in order to recreate the schema, we did a PG dump, and then we want to restore, we extract the SQL from that, and we want to store it to create the schema and all the objects, effectively an empty schema. But if we want to rerun this process, so it fails for whatever reason, right, and we want to rerun it, then we're going to get a ton of errors, because there's going to, if you do a create table and a table exists, then it'll fail. So what we had to do was we extracted the SQL that the PG dump produces, and then we have to add the if not exist clauses for tables. You have to add, all replaces for your functions and views. And the tricky ones were ones where you had to identify constraints. So you had to put in a little procedural block in there to say, does my constraint exist? If it doesn't, then you can create it. So that had to go through the entire PG dump file to make it rerunnable. It would be kind of nice if it did it automatically.
And maybe the other one is the things that were old and needed to be changed because we are upgrading version 2. So I think that maybe the operator class family, and also the customization that the client wanted to do, they wanted to change the owners of some objects, so some grants fails. So there were a lot of things that failed just on a normal dump restore, even if it is the first time. So we have to incorporate all that into this initial manipulation of the export. No?
That's right. So in terms of the grants and ownership, they wanted all the objects to be owned by one owner, but in the source they were owned by all sorts of people. So that had to be replaced, and there. In the cloud, you don't get super user, so you get a pretend super user, so you can't do things like operator class and family. So we used a lot of sed and awk to edit those files, and it was kind of done in that was a single step. So you'd create the SQL from the PG dump that you got, and then you'd parse that and to create the final output, so you could PG restore. Oh.
Oops. Let me do it. So this compatibility.
Okay. So this was specific to us, but you might find that there are differences between your versions. So in our example, or in our way of doing things, we found that any array didn't exist anymore, and it had to become any compatible array. So just be aware there are differences in versions and compatibility like that. So we had to code around that. So we had some storage space issues. So I'll quickly gloss over these.
No, but let me see the small thing here. The interesting thing is in the cloud, you have automatic extendable space for the storage. We had that enabled, and anyway, we got this error. That means that the speed that the import was executing didn't allow the cloud provider to extend the storage. And because we are running in parallel, probably that also helped to get this kind of errors. No? So we had to actually tweak it a bit, the initial provisioned size to match and avoid these kind of issues, no? Which is a bit silly, but well, it happens.
The other thing you have to do with cloud storage is once you've added it, you can't take it, you can't go back again. So you don't want to over allocate because it's just money down the drain. So what we've got here, again, the same temporary space.
Yeah, I can explain a bit about this. This is really a bit obvious again, no? You are creating a big index and you need to change the parameter. They say, well, you do the proper changes, but when we were using filters in PC Logical to say, because they wanted to not to copy all data for some big tables, and you add a filter, for some reason the copy command for those large tables ended up creating a temporary file on the source, even when it's not needed, because I troubleshooted a bit, and it's an old version, it's 9.4 something, so I mean, we don't care much. We just saw that, but this production, we were not allowed to change that. So we find these simple problems that takes a bit to troubleshoot because the generic error appears on both sides, no? On the source and in the target. And of course, the problem sometimes is in the source, sometimes is in the target, not on both.
Okay, sometimes the subscriber remains down. And what we found was that you're limited to the amount of memory that you have on a cloud SQL limits you to the number of subscribers you can have. So sometimes, even though they want only I don't know 64 gigabytes as RAM, it couldn't fit that many. We couldn't have as many subscribers as we needed. So we had to temporarily increase the RAM in order to have more max processes. So there's a kind of a bug trying to replicate normal tables to partition tables. A whole cluster crashed, which causes a problem because they'd already gone live with some of them things in the cluster. So the whole cluster crashed, and it enters a crash loop. So every time it started up, it crashed again. So what you had to do was you basically had to disable PG logical extension at the Cloud SQL level before you could bring the cluster up and then drop the subscription. So basically, you couldn't do that.
Just to expand a bit more the idea is this is one of the customizations that the customer wanted to implement, saying they have a really big table on the source and they wanted to have partitioning on the target. So we did that customization on the schema creation. But later, when we enable the replication, the data copy, the initial data copy happens, reaches to that table, and that happens. That is a limitation that we found in this document from EDB. For us, it was like a bug because its replication started, and for some reason, it crashes on the target. And when it starts, because it is a PC logical thing, it tries to start PC logical, and it crashes again. So it keeps in a restart loop. And as Luke said, we were migrating in waves, means that some databases were already productions because we're part of some other wave on this instance because they changed the mappings. And this caused an outage, actually. We didn't know, we didn't find this problem during the test because it's the kind of things that the tables were not that big. They probably introduced the partition of this table in the middle of the process, so initially we were not aware or we didn't test it. So it's a big, strange, but it could happen, no?
So these are quite interesting ones where we have a table and they've got two parents. So they used inheritance and they wanted to continue using inheritance, which isn't compatible with declarative partitioning, but in some cases they still wanted to use it. And it kind of depended on which way round the inheritance clause was. So if we basically what we got was the columns were out of order and they needed to be in the same order. So if we just swapped around the inheritance order, the order of the columns came out properly. So it's something to be aware of if anybody's using inheritance. And so what was happened was that you can kind of see, right? So the parent table starts off with column 1 and 2, parents 1 and 2. The child table comes in. He creates his own column, and then we add a column to the parent table, which adds a column afterwards here. Oh, this has gone on a bit.
Oh.
This is rubbish.
Yeah, really? Okay. No, let's go back. Yeah, here.
That's a dual parent. Oh, you missed a slide. Right,
oh, okay.
I think. Doesn't matter. So this is actually slightly different from the one that we had, which was, that was the column order with the dual parents. This is a column order with the order creation time. So it's slightly different scenario, whereby, as I was like saying, your parents get a table, your child adds a column, add a column to the parent, then you add another column to the child, and then you add a new child table based on the same parent. When you've got that sort of column order, you can never get it right on a restore, okay? Because on the restore, it comes out and looks like this. So the parent table is always going to look right, but the child table, the first child table that you created, that's always going to be wrong, and the second child table, that's okay. So how do you fix that? So what you have to do is essentially replay what was done initially. So here we've got child one. Child one is bad. Okay. So in order to get child one good and child two good, you have to first of all drop the parent column, get rid of P3. So now everything's bad. Now everything's bad. Now everything's bad. And then you add the parent column back so that now that child 1 is correct, but child 3 is bad, child 2 is bad. And then you have to recreate, essentially, drop child 2 and recreate it with the original inheritance clause, and that fixes it. And obviously you have to do that without data in it. So kind of really confusing. Did you want to say something else?
Yeah, we have 2 minutes left, so probably let's go a bit faster with this. So you have, for reference, you can download later and check all this. I think the interesting part, well, maybe is this, that there was a bug.
Yeah, so there was a bug here that, so when we're doing our validation tests, we do it just account star, right? So account star from P1 was getting this value, and it was different to the value that we got the target. And we think, oh, I know we've got a data issue. But when we did a actual select star and let it all come out on the terminal, at the end it said the number of count was this, which was actually, this is the total that was on the target. So the source was wrong, right? So what we did is when we issued a vacuum full on the table on the source, the count came out. So I don't know if that's a bug or what. It seems like a bug to me, but.
And yeah, but
this was so in our validation program, we used Python. Python doesn't handle automatically, at least, years above 999. For whatever reason, they had a year of 10,022. I'm not sure what it was, but basically what we had to do, Postgres handles it, but Python doesn't. So we had to code around that. This is quite an interesting one. So this one we were getting kind of floating point differences, very, very small differences. So you see 6.1, 6.09, and that was essentially because a value had changed, or this initialization parameter had changed between 12 from 12. So So we were going from 9.6 to 14, so it changed in the middle for us. So, so consequently, when it tried to compare the two values, it was getting it wrong. So once we changed this to match the 9.6, then it was we were able to validate successfully.
Yeah, and I think let's go to maybe the lesson learners. So I think it's a bit obvious. It's just repeating everything that we say here, but the initial proof of concept that we didn't cover all the scenarios. So when we did the initial estimation of the project, it wasn't actually that good because all those problems appeared later. No? Most of the things that we described appeared during the testing, not really during the initial proof of concept. And the thing is, as we do consulting, we have to do some money associated with the work. And it's really hard to say how much it will take you if you don't know all the problems that you are going to face. No? So it's never enough to say you have a buffer for unknowns. No? So this is like, for reference, all the migrations should be simple, but you could face a lot of problems that are small, but it takes you time to resolve. No? And we discovered all these customizations also as the project progressed. They were not really clear at the beginning, even if we spent some time trying to discover all that. Again, we know how to do that. We have done that a lot of times. And anyway, we hit, again, the same kind of problem, which means not all the customers are the same. No? You could hit some customer which is, has these particularities that it's hard to discover what they want, no? Probably. Then the two other thing is the validations at the end. We, of course, try to use some open source tools. We have challenges. We ended up writing the tool by ourselves. We have some details in the appendix. And also, we have to change the orders to do it earlier because in some of these bugs or these problems we described actually needed to be discovered earlier. No? And probably the message is that the PC Logical extension is really simple to use. So this will be the go-to tool for migrations because it's flexible and allows you to implement a lot of customizations. So you need to work only on the automation part. No? Try to use it to make it easy for you to handle more databases. And the last one probably that is obvious after we saw all this, that when you go to a managed services, they charge you mostly for the CPUs. So when you go to the chart of the prices, you always see the storage and this and that, but the main driver of the cost is CPUs. So in our case, having probably more memory is better because they don't charge you for the memory. You have better performance. So small things that we discovered when we did the cost optimization at the end of the phases of the project. Now, we have a lot of references and I know a lot of here code in the appendix about the different parts that we did. So when you download it, you can check it. So I don't know if you have any questions.
Well, thanks a lot for now. We actually do not really have time for
well,
questions.
we're going to do it
again,
outside.
It's a coffee break, so
Okay.
it's your decision if you have any questions. First of all, you will share the slides.
Of course.
Yes.
Okay. Oh, yeah. Of course. Any questions? Oh, everyone's
Nope.
baffled.
There.
Hi, thank you for speaking, but I have a quick question where we can find that magic bash script.
Yeah, this is finished like 1 month ago. We didn't still publishing nothing. So we are in the process of publishing and maybe decide what to publish, but we probably will publish something for sure. Because this is the customer thing, no? So we need to recreate to avoid to share things that from the customer. Yeah. I know.
Okay, thanks.
Any other questions? Well, good talk, obviously.
Right, thank
So, give them a hand.